So in a previous video, we looked at the graphs, the base graphs of sine and cosine, and we saw they both have a domain from negative infinity to infinity. They have a range from -1 to 1, and their base period length is pi. So it's the interval from 0 to 2 pi. And we kind of know they both have this wave type shape in their graph. And so this time we want to look at the other four functions. So tangent, cotangent, secant, and cosecant. And we could do kind of the same thing where we graph the unit circle and then kind of unravel it to see what that looks like. But I think this time we can just do the same thing by plotting some points. So computing some values of tangent and our trig functions and seeing what the graph looks like when we start plotting those points as x and y coordinates. So first, let's start with tangent. And so for tangent, we could look at maybe angles. We could start at 0. We could do pi over 4, and then pi over 2, and then 3 pi over 4, and pi. So we'll see what that looks like. Okay, so tangent of 0 is 0. Tangent of pi over 4 is 1. Tangent at pi over 2. So this is kind of weird. Remember, tangent is the y over the x coordinate on the unit circle. And at pi over 2, the coordinate is 0, 1. And so if we do y over x, we get 1 over 0. And that is undefined. And so we have these weird positions, these weird places in the tangent graph where it's going to be undefined. If we do tangent of 3 pi over 4, that's second quadrant, so it's going to be a -1, and then tangent of pi is 0. So if we want to kind of plot these as coordinates on the graph, remember the theta, the input, is now x, and tangent is the y coordinate. So we started with 0, 0 as our first point there, and then we had pi over 4, 1, and then at pi over 2, it's undefined. If you remember from your pre-calc algebra, whenever you have a function that's undefined because you're dividing by 0, it created a vertical asymptote. So we have a vertical asymptote at pi over 2. And then at 3 pi over 4, we have a -1, and at pi, we have a 0. Okay. If we continued going at 5 pi over 4, we would get a 1 again. And then at 3 pi over 2, we would get a vertical asymptote. And so our graph is going to look something kind of like this. So remember, with the asymptotes, the graph approaches the asymptote, but it never actually touches it. Okay. And so we're going to get this. Let's go backwards a little bit just to make sure we can see maybe a pattern. So we started at 0. Let's go, let's think about rotating in the circle clockwise down in the fourth quadrant and look at a negative pi over 4. If we do that, tangent at a negative pi over 4 is a -1. And if we look at a negative pi over 2, it will again be undefined. So that means at negative pi over 4, we're at -1. And then negative pi over 2, we have another asymptote. So that's sort of what the tangent graph looks like. And it will continue repeating this pattern forever and ever. So if we kept going to the left of negative pi over 2, so if we went to -3 pi over 4, we'll have a +1, and it will kind of approach down towards the x-axis. So we have this increasing type function. It's not so much a wave like sine and cosine were, but it does have this repetitive pattern, this periodic pattern. So how much of this graph do we need to keep in order to sort of copy and paste it and get the whole thing? Okay, and so if we look here, if we went from negative pi over 2 to positive pi over 2, so we kept that, just that's only a length of pi. We get this increasing graph, and that graph, if I copied and pasted that to the right, I get the same thing from negative or from positive pi over 2 to 3 pi over 2. And I would get the same thing over and over again. So I really only need to keep the graph from negative pi over 2 to positive pi over 2. This is the 1 period interval, okay? And that has a length from one end to the other, a period that is equal to pi. Okay, so that's a little different than what we saw with sine and cosine. With sine and cosine, the period was 2 pi. And with tangent, it's going to just be pi. Okay, and again, our standard period is from negative pi over 2 to positive pi over 2. We do not need to, or we can't actually include the endpoints, right? So I'm using parentheses on that notation there because we have asymptotes and we can't include those pieces in sort of our interval. Okay, so that's what tangent looks like. It's an increasing function. It's 1 period graph, has a length of pi, and sort of the standard portion of the graph that we look at is from negative pi over 2 to positive pi over 2. All right, let's do kind of a similar thing with cotangent. We'll start at a little different point here. We'll start at 0 again, I guess. So let's think about cotangent. So we'll track around the unit circle. So cotangent of 0. So remember, cotangent is going to be the x value divided by the y value from the unit circle. So at 0, the point that we have is 1, 0. And so if you take the x over the y, that's 1 over 0, which again is undefined. So we're going to have an asymptote where x is equal to 0, a vertical asymptote. If we keep going, so we'll do pi over 4, pi over 2, 3 pi over 4, and then pi. Let's see what we get. At pi over 4, cotangent is a 1. At pi over 2, cotangent is 0. At 3 pi over 4, it is a negative 1. And then at pi, the coordinate for pi is negative 1, 0. So we're going to have negative 1 divided by 0, because again, it's the x coordinate over the y coordinate. And again, that is undefined. Okay, so if we kind of graph what we have here, we have a vertical asymptote at x equals 6, or sorry, at x equals 0, and we have a vertical asymptote at x equals pi. At pi over 4, we have a y coordinate of 1. At pi over 2, it's 0, so that's our x-intercept. And then at 3 pi over 4, it is a negative 1. Okay, so we have a similar kind of shape that we saw with tangent, but this time the graph is actually decreasing. So tangent's an increasing function. Cotangent is a decreasing function. This section of the graph that we have here, this is from 0 to pi. And again, I'm not including the endpoints. I'm using parentheses in my interval notation there because, again, we have asymptotes on the end. And the length of the period is also pi. Okay, if I were to continue going around the unit circle, we would end up having the same values. And so we're just going to see the shape kind of repeat itself over and over again. All right, so it'll look kind of like that. So we only need to keep that 0 to pi portion. I mean, we have the whole graph, right? It extends from negative infinity to positive infinity. We only have to worry about 1 period of it being from 0 to pi. I forgot to talk about this with tangent, but for the domain and range. So the domain is trying to describe this is going to be a little harder here. The domain is everything. We can use any x value except for 0, 1 pi, 2 pi, 3 pi, 4 pi, and negative 1 pi, negative 2 pi, and so forth. So the domain, we could maybe say x is all real numbers except for x cannot equal n pi. So n is any integer. So it can't be a multiple of pi. All right. And for the range, Notice the graph extends upwards. We have a little arrow on the graph. It extends upwards to infinity and downwards to negative infinity. So the range is negative infinity to infinity for cotangent. Let me run back and do that with tangent here. So what is our domain? This one's a little harder to write in our range. Okay, so for the domain, notice this time we have asymptotes at all the pi's over 2. Okay, so we need to think of this at all the odd pi's over 2. So there's different ways we could describe odd numbers, but maybe 2n plus 1 times pi, and then over 2. And that will make sure that this is where what x cannot be equal to. And then the range would be from negative infinity to infinity, because again, the graph extends upwards. So again, this 2n plus 1 is just an odd, it's a way of expressing all the odd numbers. So if n is any integer, 2n plus 1 is going to be a positive number. Okay. Doesn't matter what you put in for n, it will be an odd number. All right, let's take a look then at cosecant and secant. All right. So the easiest way maybe we could do this would be to remember what the reciprocal functions are. So remember, cosecant is the reciprocal of sine. So let's go through and compute some sine values, and then we'll look at the reciprocals to see what cosecant's going to look like. So if we do, let's just do 0, pi over 4, pi over 2, 3 pi over 4, and then pi. And let's just stop there for now. Sine, and let's compute the sine of these. So sine of 0 is 0. Sine of pi over 4 is a root 2 over 2. Sine of pi over 2 is 1. Sine of 3 pi over 4 is again a root 2 over 2. And then sine of pi is back to 0. So remember, cosecant is the reciprocal of all these. The reciprocal of sine is undefined. The reciprocal of root 2 over 2 would be 2 over root 2, which if you rationalize that to root 2 over 2, you just get a square root of 2. The reciprocal of 1 is just 1. The reciprocal of root 2 over 2, again, we just saw that's root 2. And the reciprocal of 0 is 1 over 0, and that is undefined. Okay, so just kind of looking at kind of what we have so far, we know that if theta is 0, or in this case, since we're talking about theta as the x value, if x is 0, then we have an undefined value. And so that means we're going to have an asymptote again. Okay, so at 0, we have a vertical asymptote. And then at pi over 4, the value of cosecant was square root of 2. Now, square root of 2 is about 1.4. So we'll just kind of eyeball and estimate there. At pi over 4, it's about 1.4 above the x-axis. At pi over 2, it is a 1. At 3 pi over 4, it's a square root of 2 again, which is about 1.4. And then at pi, it is undefined. So we're going to have a vertical asymptote. Okay. And so this is going to create kind of an upwards opening. It's not a parabola, but you might sort of think it looks like one. But it's not shaped like a parabola. But we have this upward opening bowl kind of shape. But that's not the whole graph. Okay. So we need to keep going a little further. Let's try, let's do 5 pi over 4. Let's do 3 pi over 2, 7 pi over 4, and then 2 pi. Okay, so 5 pi over 4 sine is going to be a negative root 2 over 2. 3 pi over 2 sine is a negative 1. 7 pi over 4 sine is again a negative root 2 over 2. And then at 2 pi, it's a 0. And let's do the reciprocal. So the reciprocal of a negative root 2 over 2 would be a negative root 2. The reciprocal of a negative 1 is still a negative 1. Negative root 2 over 2 again becomes a negative root 2. And then 0 is undefined. Okay. So if we plot those points at 5 pi over 4, we have a negative root 2. 3 pi over 2, we have a negative 1. And then at 7 pi over 4, we have a negative 1.4. And at 2 pi, again, we have a vertical asymptote. And so this time we're going to see sort of it's not a parabola, but we have this sort of bowl shape opening downwards, so it's concave down. If we kept going, so that was a full loop around the unit circle. If we keep going, it will reproduce this same shape. Okay. So the graph that we're looking at here, it starts at 0 and it runs to 2 pi. So our period here is 2 pi. And where are we going to have asymptotes? So we have one at 0 pi, 2 pi, and so forth. So 3 pi, 4 pi, 5 pi. So all of our asymptotes are where the function's undefined, and they're all of the integer values of pi. So we could just think x cannot be n pi, and that would be our domain. What would our range look like? So the graph goes upwards to infinity, and as we come down, we stop here at 1. There is nothing on this graph between 1 and negative 1, and then it goes down to infinity. So our range would be from negative infinity to negative 1, unioned with 1 to infinity. Okay, so it's a little different. Okay, one way to kind of help remember the graph of sine or cosecant is that is the reciprocal. Because it's the reciprocal of sine, you could actually first draw our sine graph in here. Okay, and if you notice the sine graph, where the sine graph kind of in the first half of the graph, it's sort of this concave down shape, right? It goes from 0 up to 1. The cosecant graph reflects it upwards. So if the sine graph kind of is opening downwards, the cosecant graph is opening upwards. And then the second half of the graph, sine is kind of opening upwards, and the cosecant graph is opening downwards. Where sine hits the x-axis, so these 3 points at 0, pi, and 2 pi, so that's everywhere sine is 0. Remember, when you do the reciprocal of 0, you get an undefined value. So we're going to end up with asymptotes where the sine graph hits the x-axis. And we're going to see a similar thing happening with cosine. So for cosine, I'm going to actually apply that idea. So we know secant is the reciprocal of cosine. So let me draw the cosine graph. So cosine would start at 0, 1, and then it goes through pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and then 2 pi, 1. And so the graph of cosine is going to look kind of like this. Okay, now that's cosine. Now, if we do a reciprocal of that, remember, anywhere the cosine value is a 0, the reciprocal is going to become 1 over 0. And 1 over 0 is undefined, which means anywhere we have an x-intercept, we're going to have a vertical asymptote. So cosine is 0 at pi over 2 and 3 pi over 2. So at pi over 2 and 3 pi over 2, we're going to have vertical asymptotes. Okay, and then remember, the graph is going to curve away in the opposite direction. So from 0 to pi over 2, the cosine graph is sort of curving downwards, so the secant graph is going to curve upwards. So it's going to start at the same point as 0, 1, but then it's going to shoot up. It's going to go upwards to the vertical asymptote there at pi over 2. And then between pi over 2 and 3 pi over 2, it has to touch the same place here at pi negative 1, but then it's going to curve downwards to the left and downwards to the right, so as it approaches those asymptotes. And then the last little section here from 3 pi over 2 to 2 pi, again, it will have a point at 2 pi 1, and then as we go towards the left, towards our asymptote, it will curve upwards. And it has to curve upwards because the cosine graph is curving downwards. Okay, so they're reciprocals of each other. They go in the opposite direction. So this is the graph of cosine, okay? Cosecant. It has a period of 2 pi because it's basically just the reciprocal of cosine. So, and cosine had a graph of 2 pi. For the domain, again, this is a little harder to write, but what x values do we get vertical asymptotes? So it's all of the pi's over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2. So it's odd pi's over 2. So we could do, again, that same thing, 2n plus 1 times pi over 2. And that's what would be the domain restrictions that we have. Okay, so x can be anything except for those odd pi's over 2. And then for the range, it's going to be the same thing as it was for cosecant, right? We can see the graph extends upwards to positive infinity. It also goes downwards towards negative infinity in the middle. But there is nothing between 1 and negative 1. There's no part of the graph between those. So the range goes from negative infinity to negative 1. And we're going to union that with positive 1 to positive infinity. So that would be our range. Okay. So very similar to secant. Secant and cosecant are very similar to each other, just a little different on the domain. They both have periods of 2 pi. So the only functions that don't have 2 pi as their period would be tangent and cotangent, right? They're both just periods of pi. All right.